All right, everybody. Well, welcome Banjo Obayomi. So, if you could describe in one word why this conference is your favorite, what would that word be?
Open spaces.
Wait, is that
Open space.
open space?
Yes.
There's no space between open and spaces,
Exactly.
right? Okay, gotcha. Ready?
Let's do it. Hey guys, so I'm Banjo Obayomi. I work at 26 Labs. We do a lot of cool work in machine learning, AI, and the cybersecurity realm. I'm going to talk about how you bring a DevOps culture to machine learning research. So people that come from the machine learning background are in the academic world. The academic world is focused on answering a question through research. They'll get posed a question, they want to figure out an answer, and they want to iterate on how they're going to solve this problem. The workflow usually starts with a bunch of grad students get together. They're given some kind of task so they can pass their class, and they iterate on that to produce a research paper. And that research paper is usually a one-off silo. It gets submitted to a conference, and then it's there. But it's different at each university. All of them have different papers they want to submit, different conferences, different agendas, different goals, and they're really only reproducible for that one thing. So how do you scale that out if they go somewhere else? And data science is very in demand. It's the #1 job across the US right now. So a lot of people are graduating from institutions and going into commercial government spaces, having this research paper background and not really any kind of DevOps way of doing this. So when we think of DevOps, we think of using tools, techniques, and mindset to help optimize a process, accomplish a goal. But these people aren't really trained in that because they're just submitting papers. And then when we think of machine learning, we're about a data analysis on accomplishing a task. So machine learning comes from getting data, training the data to make a model, and that model is then used to make predictions, analyze something, learn from data. So data is the forefront of any machine learning process. But we really want to pass on a mindset of ownership of data. How do we know where our data is, where it's coming from, and how we can utilize this in a meaningful fashion? So when we think of techniques of the software development, Agile is a big one. We have 2-week sprints. This is what we're going to do, how we're going to solve this. But when it comes to data, data can happen anytime, anywhere. So you need to have a different mindset. A 1-day sprint. How can we analyze our data in 1 day? So there are tools such as DVC, Data Version Control, which is basically Git for data. With this tool, you can understand where your data is, version it, where it's being put in pipelines, how it's being accessed, who's accessing, so you can better understand the data. By understanding the data, you can also collaborate with that data. And also, you want a place to back up your data if something goes wrong, because that's often mistaken. We also want to foster a mindset of accountability. Accountability makes you sure that you trust where this is coming from, you know what's going on, you're committed to completing the job, you're responsible for what's going on. You know that your data, your process, your pipeline is going to be accountable. And the way to look at that, if we can think of repeatability and reproducibility. I want to be able to repeat my experiment with a high degree of confidence. I want somebody else to reproduce my results so I know that I'm not a single point of failure. So machine learning, there's a tool called TensorFlow Extended, which is basically a way to encodify a machine learning pipeline into a simple set of processes, starting from collecting data, training a model, and deploying it to production systems. And it's pretty cool because you can encapsulate the entire machine learning pipeline in about 20 lines of code, showing where you got your code from, your data from, how the model is being trained, what kind of training variables are passed into it, where it's getting deployed, et cetera. And when you can do that, you can have metrics, meaningful metrics to explain what is going on with your pipeline, how your experiments are being run. But there's a different way of explaining different metrics to different stakeholders. Most of the time, machine learning engineers are using things called Jupyter Notebooks, which allow you to encodify what you're doing, what experiment is happening. There's also pair programming. Hey, see what I'm doing. And then they like to make pretty graphs and PowerPoints explain all my experiments. But sometimes you need a way to encapsulate all that experimentation into one framework. So there's a tool called MLflow that allows you to encodify what your experiments are going to look like, what the outputs are, what came in, and it allows people a central location to understand data. Data transparency is very important if you want to make data-driven decisions because it allows collaboration and it allows for better insight of what's going on in your experiments and pipelines and how you can make better decisions for your process. So in total, basically, if you build it, you own it. You want to be able to have the tools, techniques, and mindset to orchestrate what's going on with your machine learning products so they can be utilized in your organization. Thank you.